this lab is to determine the pH, pOH, hydronium ion concentration, hydroxide ion concentration of 3 different acids. Titration is used to determine molarity when an acid is combined with a base in a neutralization reaction. In this reaction, water is formed, a neutral substance. An acid's concentration can be determined when added to the base. When the base and acid are equal, their pH is 7. As the acid's pH gets closer to 7, its concentration rapidly increases. So small amounts of the base have to be added at a time. All concentrations of acids can be determined using formulas, logs, and anti-logs.
Goggles, gloves, an apron, closed-toed shoes were worn for safety during the lab. Hair was tied back in a bun. Two clean bureaus were set up. The acid burette was rinsed 3 times with the acid that was used in the titration. Then the base burette was rinsed 3 times with the base solution that was used. The first burette was filled to a point above the 0 millimeter calibration mark with the acid of unknown concentration. Some acid was released from the burette to remove any air bubbles from the tip and to lower the volume to the calibrated portion of the burette. The volume of acid was recorded in the burette to the nearest 100th milliliter as the initial volume. The volume was taken at the bottom of the meniscus. The volume of acid that was determined flowed into a clean Urine-Meyer flask. The initial volume reading on the burette was subtracted from the final volume. This was the exact volume of the acid released into the flask. The measurement was reported to the nearest 100th milliliter. 3 drops of phenolphthalein were added to this flask. The other burette was filled with the standard base solution to a point above the calibration line. The concentration of the standard base was known to a certain degree of precision because the base was previously titrated with an exact mass of solid acid, which is the primary standard. Some base was released from the burette to remove any air bubbles and lower the volume to the calibrated portion of the burette. The volume of base was recorded to the nearest 100th milliliter and was used as the initial volume. The volume was recorded at the bottom of the meniscus. The Urine-Meyer flask was placed under the base burette. Base was slowly released from the burette into the flask while the contents were constantly stirred. The pink color of the indicator faded with swirling. The titration was near the end point when the pink color stayed for longer periods of time. After all measurements were taken, the flask's contents were dumped down the drain to clean the flask. The burette and titration setup was cleaned and all materials were put back in the correct places.
Now we are going to discuss the calculations for this lab. We are using the numbers from acid A. First, we're going to find the average volume used. You take the 3 volumes you got, add them up, and divide it by 3. Now we're going to find the average number of moles used. You have to take the molarity from the base to find this. Now we're going to find the average molarity. Use the molarity equation and plug in the moles you have and the liters of solution. Now we're going to do the hydronium ion concentration, which is just the molarity of an acid. Now for the average pH. This is just the negative log of the hydronium concentration. Now for the average OH. You have to use the OH to hydronium ratio and then divide that by the hydronium concentration. Now for the pOH. This is just the negative log of the hydroxide concentration. Now for the average volume used for the base. You take the three quantities and divide them by 3 again. For the average number of moles used, you take the molarity that we were given and multiply that by the liters of solution to get the moles of solute. For the average molarity, this was given to us in the beginning of the lab by Ms. Ziner. The average hydroxide ion concentration is just the molarity of a base. The average hydronium concentration, you use the ratio again and divide the ratio by the hydroxide concentration. For the average pH, you take the negative log of the hydronium ion. For the average pOH, you take the negative log of the hydroxide concentration. Thank you for watching, and I hope you enjoyed this lab on titrations.